All right, good afternoon, guys. So we're going to go ahead and move into section 5.3, which talks about logarithms. And if you had pre-cal already, you talked quite a bit about logs. If you haven't had pre-cal, you may have heard of them, but you probably haven't done a whole lot with them. So here's an easy way to explain logarithms. Logarithms are the inverses of exponentials. So if you look at example 1, it looks very similar to some of the things that we graphed in section 5.2. But look at the difference here. We've reversed x and y. All of the functions that you graphed in the last section had y equals 2 to the x or y equals e to the x. So x was your exponent. Now we've reversed that, which is the definition of an inverse. The definition of inverse is reversing x and y. What we're going to be talking about today is this right here can actually be rewritten to look like what I've written right down below it. It can be rewritten as a logarithm. We're not quite there yet. We'll talk about exactly how you do that later, but that's where we're headed. So if you wanted to graph the equation x equals 2 to the y, easiest way to do that would be to make yourself a little table of values. But this time, notice something. Since y is my exponent, y is going to be my input. So I'm going to plug in some numbers for y and see what happens to x. Okay, so let's say y is 0. That would mean I would have 2 to the 0. Well, anything to the 0 power is always 1. So there would be my first point I'd be plotting. Okay, then I go to the second line. If y was 1, well, 2 to the first power would be 2. Okay, next one, what would happen if y was 2? Well, 2 squared means that x would be 4. Okay, if y was negative 1, well, 2 to the positive 1 is 2. So 2 to the negative 1 would be 1 over 2, or 1 half. And lastly here, 2 to the negative 2. Well, 2 to the positive 2 would be 4. So 2 to the negative 2 would be 1 over 4. So just to give you an idea of what those points would look like if I plotted them in Desmos. So there's 1, 0, 2, 1, 4, 2, 0.5, negative 1, and 0.25, negative 2. Okay, so I want you to look at what that graph looks like right here, these purple points. Now this would keep going on forever and ever, so there would be a line going straight down and then almost straight across right up here at the top. So think about it this way. When we graphed all those exponentials in the last section, they shot up towards positive infinity really, really quickly. Now look what's happening with logs. Logs get flat on the top and they shoot down really, really quickly towards negative infinity. So that's another clue there that they are inverses. Okay? So let's say I take a look at example 2. Example 2 is where we actually start looking at the word log. Okay? Here's what they're asking me to do. If they say find something like log base 10 of 10,000, that's how I read that. Here's what they're asking me for. First thing I'm going to do, since I am trying to find what that equals, I don't know what it equals, I'm going to set it equal to x. So log base 10 of 10,000 equals x. You can actually rewrite this in exponential form. And the way that you would do that is this right here. And let me slide down where I've got a little bit more room here. There we go. Okay. The little x here that's by itself, that's going to be my exponent. So I would write it down first. The 10 and the 10,000 are going to go around it. Okay. Again, let me just reiterate how I did that. Whatever is by itself here, which in this case happens to be an x, is your exponent, because I don't know what it is. The 10 and the 10,000 are going to form the two big numbers in your equation. So they're going to go around that exponent, okay? So what they're asking you for when they say, what is the log base 10 of 10,000? They're saying, what's that exponent that makes 10 equal 10,000? 10 to the what power is 10,000? Well, that happens to be 3. So log base 10 of 10,000 is just 3. Okay? Let's say I did part B. So they asked me to find this time log base 10 of 0.01. Well, since I don't know what that equals, for right now, I'm going to set that equal to x. Okay? And I'm also going to rewrite something a little differently here. 0.01 is the same thing as 1 over 100. I'll show you why I wrote it that way in just a minute. Okay, so now if I want to change this to an exponential, here's what I would do. I would say, well, x is by itself, so x is my exponent. The 10 and the 1 over 100 are going to go around that exponent. So 10 to the x equals 1 over 100. So what are they actually asking me here? They're saying 10 to the what power gives me 1 over 100. Well, 10 to the positive 2 would give me just 100, which means 10 to the negative 2 would give me 1 over 100. So my answer there for what is that logarithm equal to is just negative 2. That's it. Okay? I'm going to skip down and pick one more of these. We will do, let's say, F. Okay? Or we'll do D, excuse me. So they want me to find out what does log base 9 of 3 equal. So we'll set that equal to x until we know what it equals. Oops. 3 equals x. Now we'll rewrite that as an exponential. So again, whatever is by itself, so in this case x, is going to be my exponent. The 9 and the 3 will go around it. Okay, so here's what we're asking ourselves. 9 to the what power equals 3? This one may seem a little tricky, okay? Because here's the thing. I could say 3 squared equals 9, but that's not what they're asking me. Think about it this way. The square root of 9 equals 3. Well, how do I write a square root as a power? Well, the square root is the same thing as the 1/2 power. So that means 9 to the 1/2, or 9 to the 0.5, equals 3. So there is my final answer right there. So what you're doing when you're finding a logarithm is you're finding what exponent makes that statement true. That's all they're asking you to do, okay? A couple things that you want to be aware of right here. Think about something like part F. If you ever see a number where your base, and then this big number here is called the argument, if you ever see something where that's the same, think about what you would be solving. You would be solving 5 to the what power equals 5. Well, that's just 1. So if you ever have a logarithm where your base and your argument are the same thing, it's almost like it cancels itself out. It cancels out to 1. So that's just a shortcut there, but if you don't remember it, not a big deal. Okay? Example 3 now says convert each of these following exponential equations to logarithms. So it's like we're going backwards. Okay? So part A, here's the most important thing I need to identify. What's my exponent? Well, in this case, it happens to be x. Okay? It won't always be, but in this case it is. So if you remember, think about what we just did in the last example. We made the number, or the letter in this case, that was by itself, the exponent. So if we're going backwards, this exponent right here, x, is going to be what goes by itself. So I'm going to go ahead and type that in, equals x. It's by itself. Then the other two numbers here are going to be my base and my argument. So I would have log base 16 of 2. So to break that down, the x is the exponent, so it's by itself. The 16 and the 2, the big numbers, form your actual logarithm here, okay? They're the base and the argument, and they go in the order that they appear. So 16 was written first in the exponential. It's also written first in the logarithm. Let's say I go look at part B now, okay? So part B, the most important thing I can identify is what is my exponent? Well, in this case, it's negative 3. So since that's the exponent, that's going to be the part of my equation that's by itself. Negative 3 is going to be the only thing that's on the right side. That 10 and the 0.001 are going to form the base and the argument of my logarithm. So I have log base 10 of 0.001. And then I'm done right there. Sometimes you will see people put the argument, so the big number, in parentheses, but you don't have to. That's up to you. All right, very last thing here, part C. Part C goes back to using some more letters here, but that is not a problem. Okay, first thing I identify is what is my exponent? Well, in this case, my exponent is the letter T, so I know it's going to go by itself. And in this case, the other two, they're not both numbers, but the big letter and number, the E and the 70, are going to form my logarithm. So e comes first, followed by 70. And there's my final answer. Okay. Example 4 is again just going backwards. So here it is in logarithmic form. They want me to put it as an exponential. So if I'm going to convert this to exponential, the first thing I've got to identify is what is my exponent? Well, what number's by itself? It's a 5. So I'm going to underline that 5. Okay, it's my exponent. I'm not going to do anything with it for right now. The 2 and the 32 are going to be my big numbers. They go around the 5. So again, identify your exponent first every time. Okay? Then we go to part B. This one will be the last one we do on example 4 here. Okay? So for part B, what's going to be my exponent? Well, again, it's the number or the letter that happens to be by itself, which in this case is an 8. So the A and the Q are going to be my big numbers. They're going to go around the 8. So if I can convert that to exponential, it will look like this. A and Q, those are my big letters in this case. 8 is my exponent, and then I'm done right there. That's an exponential form because I have an exponent. Okay? Now, here's the thing. Sometimes there will be logarithms that you can't find an answer to by hand. So, for example, if I'm looking at example 5 here, and I tried to do part A, okay, think about what that would look like. So, first thing I would do if I was going to do this by hand is I would say, okay, well, I don't know what it equals, so I'm going to set it equal to x. Okay? You'd have log 645, 778 equals x. And something I want to mention here, notice how there is no little base here. If they don't write it, it's understood to be 10. Okay, so you can write that in if you want to. Here's the problem now. If I wanted to figure out what this logarithm was equal to, I would convert it to exponential form. It would say 10 to the x equals 645,778. Well, off the top of my head, I have no clue what power of 10 gives me 645,778. So in that case, that's when Desmos comes in handy. I can walk over to Desmos here, and I can say, okay, what is the log of 645,778? And it does, I believe, make you put this in parentheses in Desmos. Let's see here. Oh, it also makes you leave out the comma. Right there, it tells me that that exponent that I'm missing is 5.81. I probably could have gotten there eventually if I had tried long enough, but it would have been a while. So my answer there is 5.81. Same thing on part B. It's understood that there's a 10 right there, that's my base since they didn't write it. Well, I have no idea what power of 10 gives me 0.0000239. So in that case, I'm going to go over to Desmos and type it in. 1, 2, 3, 4. And right there, it tells me my answer is negative 4.621. Okay. All right, very last one I want you to see. Let's say you get something like log of negative 3. See how that says undefined in Desmos? Here's why. What you would be solving if you did this by hand is you'd be saying 10 to the what power gives me negative 3. Well, there's no answer to that equation. You can't take a positive 10 and raise it to a power and get a negative number. So if you ever have a negative argument, so a negative in parentheses, you don't have an answer. So you can either say that there's no solution or you can say that it's undefined, however you prefer to say that. But you should be really happy when you see those because there's no work involved. Okay, next topic won't take us very long. You may have seen the letters LN on a button on your calculator before, or you may have heard people say something like natural logarithm. They work the same way. Here's the only thing that is different. Notice down here on example 6, when I see LN, they don't write in a base again. Well, we said on the previous problem, when you have just regular log, if they don't write in a little base, your base is understood to be 10. Well, with natural logs, it's not understood to be 10. It's understood to be E, and E is about 2.72. So let me show you what that looks like. So on part A, what's actually happening here is it's understood to be base e. That's what natural log means. That's all it means. Everything else works exactly the same way. So you would be solving by hand natural log base e of 645,778 equals x. Well, if I wanted to write that in exponential form, look at what that would look like. I would say, okay, well, what's my exponent? It's x because that's what's by itself. The e and the 645,000 here would go around it. Okay. So x is my exponent. So it would look something like that. But again, here's the problem. E is 2.72. It's a really long decimal after that. I have no idea what power I should raise 2.72 to get 645,000. So again, I go over to Desmos and I type in this time ln in parentheses 645,778, and it tells me right there my answer is 13.378. I can do the same thing for part B. Part B, if I was doing it by hand, I'd be answering the question, e to the what power gives me 0.0000239? I have no idea. So what do? I use Desmos. Natural log of 0.0000239, and it tells me that my answer there is negative 10.642. Okay. Very last example I want to do with you is letter D, and I want you to think about this one, okay? We can do letter D with Desmos, absolutely, but I want to show you how to do it by hand as well. So think about what you've got here. So you have natural log. It doesn't have a base. Because it's a natural log, it's understood to be E. So we have natural log base E of E equals something. We don't know what it is yet. Well, if I write that in exponential form, x is my exponent, okay? And the two e's are going to go around it. So you would have e to the x equals e. So think about what that's asking me here. E to the what power gives me itself? Well, that's going to be 1. So here's what's happened, okay? And again, we saw this a little bit earlier in our notes. Anytime, let me get all the way over there. My answer is 1. Anytime you have a base and an argument that are the same here, it's like they cancel each other out. Your answer is just 1. If you don't believe me, you can type that into Desmos, and it'll tell you that the natural log of E is 1. Okay? So we are going to stop right there on this section of the notes. That should get you plenty to get started on your homework. Have a great day, and please let me know if you have questions.